to do 4 of these problems with you. Right here is the notes. You're going to do them on your paper, and then you're going to finish this worksheet, and the whole thing will get turned in. So let's start with number 1. Okay, so step 1 was to simplify the radicals. So if I prime factor this 6, I know that that's 2 times 3. And on this 10, if I prime factor that, I know that that's 2 times 5. Now, since both of these are under the radical, right, and one's on the top and one's on the bottom, I can cancel those out, right? So it makes my numbers smaller, a little bit easier to deal with. So now this problem looks like this. All right, and now I'm going to rationalize. Okay, what that means is you're not allowed to have radicals in the denominator. You can have them in the numerator up on top all you want. You just can't have them in the denominator. So I'm going to multiply the top and the bottom of this fraction by the square root of 5. Okay, and the reason is now I've got 2 5s under the radical, and if you've got pairs, they get to come out from under the radical. And then up top, I'm going to multiply those together, and I'm just going to keep them under the radical. Okay, so there's number 1. Okay, number 1, all done. Okay, let's take a look at number 2. Okay, so again, step 1 is going to be, let's simplify whatever we can. So up top, you guys know that the square root of 4 is actually 2. Okay, so simplify it first. Okay. Next, I'm going to rationalize, which means I need a way to get rid of this radical in the denominator. So I'm going to multiply by the square root of 3. Now you can't just do it on the top, or excuse me, on the bottom. You have to do it both top and bottom. So when I multiply this together, the 2 stays on the outside, the 3 stays underneath. Here, these 3's get to come out, right? There's a pair of them, and there's a 5 already out there. Last time I checked, 5 times 3 was 15. So there's the answer for number 2. Okay, I'm going to scoot this up. Let's do number 4 together. Okay, let's do 4. So there's nothing here that I can simplify, so I'm just going to go ahead and start by rationalizing. I'm going to multiply by rad 6. Rad 6. Okay, so on the bottom, this pair comes out from under the radical. And up top, the stuff that's on the outside stays on the outside. The stuff that's underneath stays underneath. Now, if you look really close, this 10 and this 6 are both on the outside, right? They're not under radicals, which means it's reducible, right? I can actually divide both of those by a 2, which gives me 5 rad 6 on the top and a 3 on the bottom. Okay, you can't reduce this one because it's underneath. All right, so then the last one I'm going to do with you is number 5. Okay, it looks like a pretty simple problem. As of right now, there's nothing that I can do to it except rationalize, which gives me on the top 2 rad 2, and on the bottom, these pairs come out from under the radical. Okay, and then kind of like on the last one, I do need to simplify now that I'm done. Right, this 2 on the top and this 2 on the bottom are exactly the same. They cancel each other out. So the whole answer here is rad 2. Okay, so this is week 13, lesson 4, which is going to be on rationalizing denominators. I'm hoping that this is a review, but if it's not, I'm going to give you the 3 steps that are going to be necessary to be able to do this. So let me get rid of this little thing that's covering things up. Here are the steps. All right. You want to simplify what's given. All right. Like I'm going to give you a problem. Sometimes you might be able to reduce it. You might be able to take the square root. There might be something that you can do to make it simple at the very, very beginning of the problem. You're going to want to do that first. Second, you want to rationalize the denominator, meaning you want to try to make pairs, all right? Because once you've got a pair under the radical, then it gets to come out from under the radical, all right? And then sometimes, not always, but sometimes you're going to have to simplify again, and it just kind of depends on the problem, okay? So